Hello, my name is Pete Arthur. I'm the Technical Training Manager here at Control Techniques Americas. In this video, I'm going to be taking one of our Commander C general purpose drives out of the box, wiring it, and then commissioning it using the drive keypad. So if you're ready, let's get started. The equipment I'm working with today is one of our Commander C200 drives. This drive is rated for 200 volts and it will output 2.4 amps. I'm using one of our Leroy-Somer induction motors. This motor is equipped with an encoder, but today I'll be using it in open loop form. So let's see what's inside the box. Before I take the drive out of the box, I wanted to point out our drives ship with a mounting template that you can cut out and use as a reference when you go to panel mount this drive. It points out not only the location of the screw holes, but it also tells you that it requires four 4mm screws. So that's a nice feature. Now let's see what's inside. Unpackage it. And then we'll remove the drive. There's the drive. Okay. So here's what we have in the box. The drive itself, obviously. The drive comes with what's called a grounding bracket. This grounding bracket will be mounted here. This is a convenient spot where you can connect cable shielding to this metallic frame, which will be bonded to ground. In terms of documentation, we have the step-by-step guide that goes through and talks about installation and commissioning. Then we have some safety instructions when it comes to installation. So it talks about the type of enclosure, lifting and handling, just some basic things you need to know prior to installation. And then finally, we have the warranty registration here. So that's what comes in the box. Now let's see how to connect power. The tools I'll need to install the drive are shown here. You'll only need three things. You'll need a wire stripper to remove wire insulation. If you're going to install the grounding bracket here, those are Torx head screws. So you'll need a size T20 Torx head screwdriver, and then just a flat blade screwdriver. And this one has a 5/32 inch blade on it. So I'll begin by removing the front cover. And to do that, I'll put my flat blade screwdriver here, turn it about 1/4 of a turn counterclockwise, and then slide the cover down and remove it. Here are the wiring terminals. Starting here, these are the control terminals. So here is where you're going to be bringing your analog speed reference and your run switch. Here is a dry contact relay. This can be used oftentimes for controlling a holding brake or for indicating the status of the drive. These three terminals are marked L1, L2, and L3. Here is where I'm going to connect my three-phase power. I'll bring the ground, earth ground, down here to one of these terminals. Starting from left to right, here are the motor terminals, U, V, and W. So I'm going to be connecting my three-phase induction motor here. Next to those, we have the DC bus connection, minus and plus. And then we have the brake resistor connector here. So I'm going to go ahead and connect my power and ground. I've connected three-phase power to my drive, and I've also brought in earth ground. One thing I should point out is this ground terminal, there are 4 screw holes, and you're provided with 4 screws. My advice would be to use the inner 2 holes, one for earth like this, the other for your motor ground, and leave those outer two holes open. That's because you'll need those two outer holes to mount this grounding bracket that I referred to earlier. So it fits in like so. So that's why you'd want to leave those outer two holes open. Next, let's connect the motor. I've installed my motor wiring now. And here are my three phase leads, U, V, and W. And as with any induction motor, what I may find when I apply power and commission the drive is that the motor shaft is rotating the wrong direction. Well, what I could do is swap any two of those, but I'm going to show you an alternative method that's found in menu 5, which is a lot more convenient than rewiring the motor. I also wanted to point out the motor ground cable that I've constructed here. When you are selecting motor cable for a drive application, you should always use cable that is not only low capacitance, but also has a braided outer shield. And the reason for that is with the induction motor, the shield needs to be connected at the drive end and the motor end. So what I've done is I have created a lead out of the braided outer shield, and I've attached it and the motor ground to the ground bar here on the drive. Next thing I'm going to do is I'm going to install my control wiring. So let's have a look at the default terminal configuration first.
The diagram shown here comes from the Commander C200 step-by-step guide that ships with the drive. What you're looking at is the default configuration of the control terminals. There's two things I'd like to point out. First, Terminal 9 is a 24-volt DC user power supply. This power supply is not to be used for anything other than supplying 24 volts for the control terminal inputs and outputs. Second, Terminal 4 is a 10-volt DC user power supply, and, like the 24-volt supply, the 10-volt supply is to be used to supply 10 volts to a potentiometer when using analog voltage as a speed reference. For this video, I'm going to operate the drive in hand, or what we call keypad mode. That means I won't be using any of the digital inputs or outputs. The only connection I'm going to make is to install a jumper between terminals 9 and 11. This is a critical connection as the drive must be enabled before it will run.
I've installed the ground bar down here, connected it to the ground bar on the drive itself, and as I mentioned, the control terminal wiring for my example in this video is quite simple. The only thing I've done is I've connected a jumper between terminal 9, which is the user 24-volt supply, and terminal 11, which is the drive enable. I'm going to be operating this drive in hand mode, which means I won't need an external speed reference, nor will I need an external run signal, as I'll be doing everything from the drive keypad. The next step in the installation, I'm going to show you how to install a system integration module into the expansion slot here. It's important to note that Commander drives will accept system integration modules in frame size 2 or larger. So to utilize any expansion module, you'll need to make sure that you're using at least a frame size 2 drive. Let's see how to install the system integration module now. I'm going to be installing the system integration module now. And the first thing I need to do is to remove this green plastic cover. To do that, I'm just going to use my flat blade screwdriver and insert it into the slot next to the cover and lift up. Once you lift it up, you can simply break it out like that. The module I'm going to be installing is one of our SI Ethernet modules. This module will permit Ethernet communication in the form of Modbus TCP IP, Ethernet IP, and our own RTMOE high-speed peer-to-peer communication protocol. To install this, you simply line up the male card edge connector with the female receptacle on the integration module, like so, and plug it in until you hear it click. At this point, I'm now ready to apply power and begin commissioning. I'll replace the cover. And now we're ready to commission the drive. Before I enter my commissioning parameters, let me show you the buttons that are found here on the keypad. To begin with, the green button is the start button. This is the button I'm going to be using to start the motor when it's in hand mode, which we refer to as keypad mode. The red button is stop and reset trip. So in keypad mode, I'm going to start the motor using the green button and stop it using the red button. Then let's jump up here. This is the enter button. This button will allow me to enter a parameter change, and it will also allow me to enter from parameter display mode, which you see here, into parameter edit mode, which I'll do here in a moment. Then we have the escape button. Once I've entered into parameter edit mode, I use the escape button to back out to parameter display mode that you see here. Then we have a decrement arrow here and an increment arrow here. These are the buttons I'm going to be using to make adjustments to the parameters I'm going to use when commissioning the drive. So now, let's get started commissioning. Okay, I'm ready to begin commissioning the drive. As you can see, I've applied power to the drive, and the status display reads RDY, and that stands for ready. That's a result of my installing the jumper between terminals 9 and terminal 11. If I had not done that, the normal power-up state without that jumper would read INH for inhibit. Now the parameters I'm going to use to commission the drive are conveniently printed right on the face of the drive cover. So I'm going to begin with parameter number 1. And parameter number 1 is the minimum speed in hertz. So by default, that is set at 0 hertz. Now I want to adjust that. I want to make it 10 hertz for a minimum speed. Now I could press and hold the up button until it read 10.0. But I'd rather show you a shortcut, which I think you'll find handy. What I need to do is I need to move the cursor from the rightmost digit over to the left. And to do that, you use a combination of the enter button and the down button. So watch as I demonstrate. Press and hold the enter, and then press the down button. So now the cursor is where it needs to be, and I'm going to use the up button to make it 10. 10 hertz will be my minimum speed. Next, I'll go to parameter 2. Parameter 2 is the maximum speed in hertz. And by default, it's 60 hertz, and I'm fine with that, so I'll leave it alone. Parameter 3 is the acceleration rate in seconds. And by default, it's 5 seconds. Once again, I find that's okay, so I'm going to leave that alone. Parameter 4 is the deceleration rate in seconds. By default, that's 10 seconds. I think that's too long. So I'm going to modify that to make it 5 seconds instead. And I'm going to use the same shortcut I used before. Press and hold. And I'll make that a 0. Now I'm going to move over again. And now I'm going to move to the right. Just like that. Enter. So 5 seconds acceleration, 5 seconds deceleration. Parameter 5 is what we call drive configuration. And essentially that means where is the speed reference for the drive going to come from? By default, you see it's AU. Well, that's actually a representation of analog voltage mode, but because the keypad can't make a V, it shows up as a U instead. So as I've mentioned, I want to run this drive in hand mode, so I need to make an adjustment to this parameter. So I'll use the up button until I see pad. That means keypad. So I'm going to be running the motor using a combination of the green start button and the red stop button. Now, parameters 6, 7, 8, and 9 are the most important parameters of all because they are the ones where you're going to be entering your motor nameplate data. So the first thing I see is the motor rated current. Now earlier I showed a picture of the motor nameplate, and by default the drive will come up with the drive rated maximum current, which for this frame size drive is 2.4 amps. Well, the motor is only rated for 2.3, so I need to change this. And I'll use my shortcut, and I'll make that a 3 with the down button. So my motor rated current is 2.3 amps. Parameter 7 is the motor rated speed. Now, I have an interesting situation in the sense that I'm using a European motor that's rated for 50 hertz. By default, with US defaults, the drive is set up to run a 4-pole 60 hertz motor. The synchronous speed for that motor is 1800, as you see here. Well, I'm going to pop the nameplate for the motor I'm using up on the screen again. And as you can see, that motor is rated for 1440 RPM at 50 hertz. So I'm going to need to adjust the settings for the US defaults at 60 hertz. And what I'm going to do is I'm going to use the same 60 hertz offset between a 1500 RPM motor, which is a 4-pole 50 hertz, and I'm going to convert that to use the 60 hertz instead. So I'm going to make this 1800 RPM 1740 RPM to reflect that 60 hertz difference. So I'm going to move over, make that a 7. Now I'm going to move to the right using these buttons here, and I'll make that a 4. So this motor's slip speed is 1740 RPM. And this is another important point, is you always want to enter the slip speed, not the synchronous speed. Parameter 8 is the motor rated voltage. Well, this motor is rated for 230 volts, so I can leave that alone. And finally, parameter number 9 is the motor rated cosine theta, or the motor power factor. And in this case, the motor is rated with a cosine theta of 0.55. So I'll make that change. There. At this point, the drive is ready to run. We're ready to test our motor now. So because I'm in keypad mode, I'm going to press the green button to start the motor. And because I'd set the minimum frequency to 10 hertz, it's now rotating at 10 Hertz. If I wanted to increase speed, I'll press and hold the up button. The longer I hold it, the faster the rate changes. To slow down, we'll go the other way with the down button. Now I'm going to slow it down a little further. There we go. To show you a couple of things. First of all, you see the little underscores, the highlights. The lower one indicates that the drive is in keypad mode. The upper one indicates the direction that the motor is rotating. And in this case, it's clockwise. So I got lucky in my motor phasing in the sense that this is what I want. This is my correct direction. If you wanted to reverse that, as I mentioned, I could go in and I could swap any two of the motor phases. But what I'm going to do instead is demonstrate the use of menu 5, parameter 42, which is reverse output phase sequence. So to do that, I'll begin by stopping the motor. And now I'm going to need to adjust my user security. So I'll do that by pressing Enter. And there I'm at parameter 10, which is user security. And I'm going to change that from level 1 to all menus. Enter. Now when I press Escape, things are going to look a little different. To begin with, I now have two sets of digits. Menu dot parameter. So where you saw PR10, that's menu 0 parameter 10. I'm going to hit Escape again. Now I could change to menu 5, but before I do that, I want to show you something else. If I hit Escape again, now I have a slot menu here. The parameters for the Ethernet module will be found by making that a 1. So the way you read that is slot 1, menu 0, parameter 0. I'm not going to go into that now. I just wanted to point that out. So I'll hit Escape. Now, let's go to menu 5, parameter 42. So to do that, I'm going to come over to the menu, use the up for 5, enter, and now I'm going to use up to go all the way to parameter 42. Okay, and 142, enter. Currently it is off. I'm going to change that to on. And now watch when I run the motor. See that it's now rotating counterclockwise, yet the direction indicator still shows clockwise because we've just redefined clockwise direction. So I'll stop it. Most importantly, because I've gone outside of the basic menus, I now need to perform a parameter save to save my setting from menu 5. So I'm going to do that by pressing Enter, Enter, and I'm going to go to parameter 0 in menu 5. Any parameter 0 in any menu has the same effect. 2, 1, 0. Enter. I'm going to change this, so I enter again so it's blinking. Move up once, save, and then hit the red reset button. There. Now my parameters are saved, so I can freely cycle power and everything will be retained in the drive's non-volatile memory. Thank you for watching this video, and as always, thank you for choosing Control Techniques.